let's now look at an example to practice computing the sample covariance. I have written the formula up here for our convenience, so we can refer to it if need be. So we have a data set with 4 observations, right? Each observation contains a value of x, which is the time variable, and a value for y, which is the GPA variable. So think of this as having 4 students, right? The first student spends 1 hour studying and has a GPA of 2.0. The second student spends 2 hours studying and has a GPA of 2.2, and so on and so forth. I have given you here the sample mean and sample standard deviation of each variable. So again, whenever I do this kind of calculation, right, I like to construct some kind of table like this to help me keep track of my calculation. But if you want to just plug numbers into the formula, that's fine with me too. Just make sure you show me all your work. So let me start by numbering my columns 1 through 6. So this is column 1, column 2, column 3, 4, 5, and 6. In this example, let's calculate the covariance between time measured in hours and GPA. So the variable x is the first column. So let's see how we fill out this table. In column 4, you want to calculate xi minus x bar, right? So the idea is you subtract the mean of x from each observation of x. So for the first observation, it's going to be x1 minus x bar, right? x1 is 1, x bar is 2.25. So this is x1 minus x bar, which is negative 1.25. Okay. Now for the second observation, it's going to be x2 minus x bar, right, which is negative 0.25, right, because it's 2 minus 2.25. Then if you keep doing this for the other observations, you're gonna have x3 minus x bar, and then x4 minus x bar. Now in column 5, you want to do the same thing, but for the y variable instead. So in this case, you're gonna have y1 minus y bar for the first observation, which is gonna be equal to 2 minus 2.3, which is negative 0.3. For the second observation, you're gonna have y2 minus y bar, which is gonna be equal to negative 0.1. And then you have y3 minus y bar, and then y4 minus y bar. Now in column number 6, for each observation, you want to multiply the numbers in column 4 and column 5 together. So for the first observation, you're going to have x1 minus x bar times y1 minus y bar. X1 minus x bar is negative 1.25 from here. So it's negative 1.25 times negative 0.3 from here. That gives you 0.375. And then you do the same thing for the other observations, right? So if you do the same calculation for observation 2, you're going to end up with x2 minus x bar times y2 minus y bar. Let me rewrite it here. So you have x2 minus x bar times y2 minus y bar. If you do that for the third observation, you have x3 minus x bar times y3 minus y bar. And then for the last observation, you have x4 minus x bar times y4 minus y bar. Okay. Now notice that if you add all the numbers in this last column, you have the summation of xi minus x bar times yi minus y bar for I going from 1 to 4. Right? In this case, we have 4 observations, so I runs from 1 to 4, which is going to be equal to x1 minus x bar times y1 minus y bar plus x2 minus x bar times y2 minus y bar plus x3 minus x bar times y3 minus y bar plus x4 minus x bar times y4 minus y bar. Right? But then this quantity is exactly the numerator in our formula up here. Okay. So this is equal to numerator in the formula. Okay. So then to get the covariance, all you have to do is to divide this sum, the sum of all the numbers in the last column, by 4 minus 1, which is 3, to get the covariance. Okay. So at this point, you should pause the video, try to figure out this table on your own, and then continue. Now you should end up with a table like this, right? And so the sum of all the numbers in the last column is going to be equal to 0.86, and so the sample covariance is going to be equal to 0.86 divided by 3, which gives you 0.2867 for the sample covariance of time measured in hours and GPA. Now note that in this data set, I also have time measured in minutes. Okay. At this point, you should pause the video and calculate the covariance between time measured in minutes and GPA. Okay. Just to practice. Once you have done that, you can proceed with the video. Okay. So now I hope that you have calculated the covariance between time measured in minutes and GPA, and hopefully you got something that looks like this. Right? So the sample covariance is the sum of the numbers in the last column, which is 51.6, divided by 4 minus 1, which is 3, so you have a sample covariance of 17.2. Now here comes the problem with the covariance. Right? Note that basically in this problem, we have the same two variables. Right? We have the same GPA and the same amount of time studying. So an hour corresponds to 60 minutes, 2 hours correspond to 120 minutes, and so on and so forth. Okay? Because you have the same amount of time studying and the same GPA, you should expect that the relationship, so we have, let me see here, same amount of time studying and GPA. So what we should expect is that these variables, right? These variables, the relationship between time in hours and GPA and time in minutes and GPA to be equally as strong. However, our calculations show that we have wildly different numbers, right? So here we have 17.2, previously we have 0.28, okay? And so the value of the covariance depends on how you measure your variables. Right, so covariance depends on how variables are measured. This means that we cannot use a covariance to compare the strengths of the relationship. Can use covariance, right, to compare strengths of the relationship among different pairs of variables. Okay, and this is a disadvantage of the covariance. Okay. So in this video, we looked at how to compute the sample covariance in a sample, and we note the weakness or the disadvantage of the sample covariance, which is that it is dependent on the unit of measurement.